Hi, good day. So for today's topic is all about the Cauchy-Riemann equations. I am Fatima Tutor and I will be discussing this topic. So the Cauchy-Riemann equations, named after Agustin Cauchy and Bernard Riemann. The Cauchy-Riemann equation is one of the most fundamental in complex analysis. This provides analyticity of a function. In real function analysis, analyticity of a function depends on the smoothness of the function on X. But for complex function, this is no longer the case as a limit can be defined in many directions. The goal is we need to fulfill the two partial differential equations. First, du over dx is equal to dv over dy. And the second equation is du over dy is equal to negative dv over dx. So a necessary condition that w is equal to f of z is equal to u quantity xy is equal to iv quantity xy be analytic in a region R is that in R, u and v satisfy the Cauchy-Riemann equations. As a recap, an analytic function f of z is equal to u quantity xy plus iv quantity xy is one that can be represented in terms of complex variables and has a derivative at every point in its domain. So the function u, quantity xy, and v, quantity xy, are sometimes called conjugate functions. This means that they satisfy the Cauchy-Riemann equations. It should be fulfilled the two partial differential equations. Now, let's have an example. Consider the function f of z is equal to z squared. This function is analytic everywhere in the complex plane. Let's find its real and imaginary parts. Using the relation z is equal to x plus iy, we have f of z is equal to x plus iy squared is equal to x squared plus 2ixy minus y squared. From this, we can identify u quantity xy is equal to x squared minus y squared, and v quantity xy is equal to 2xy. Now, let's compute the partial derivatives. du over dx is simply 2x, while dv over dy is equal to 2x. They are equal. Now, let's continue on the second equation, which is du over dy is equal to negative 2y, and negative dv over dx is equal to negative 2y. Thus, f of z is equal to z squared is analytic and its real imaginary parts are conjugate functions satisfying the cauchy-riemann. Now, let's have another example. Let's take the complex function of f from C to C. Given us the identity function of z is equal to z, which means that the number z is simply mapped into z again. Now, because we want to deal with partial derivatives with respect to x and y, we have to write z as x plus iy. Hence, we do this change on the left-hand side and on the right-hand side. And then you see the real part is our function of u, and the imaginary part is our function of v. Now, we just want to check if the cauchy-riemann equations are satisfied. Let's write the partial derivatives. Du over dx is simply 1, and dv over dy is also 1. Therefore, they are equal. Now, let's move to the second equation. Du over dy is equal to 0, and negative dv over dx is equal to 0. Thus, function of z is equal to z is a holomorphic or analytic because both cauchy-riemann equations are fulfilled. Next, let's have another example. Let's take the complex function f from C to C. Given as the identity, f of z is equal to z bar. We need to rewrite x and y. So f quantity x plus iy is equal to x plus I minus y. Of course, this is not complicated since the imaginary part just gets the minus sign. Now, let's have its partial derivatives, where du over dx is equal to 1 and dv over dy is equal to negative 1. Since they are not equal, thus, we can conclude that f of z is equal to z bar is not holomorphic or analytic because the first equation is not the same. That would be all. Thank you for watching.